In this lesson at 10.5, we're going to continue to look at angles, and we're going to look at their relationships in circles. The first one we're going to look at is tangent and intersected chord theorem. This theorem basically is the same like whenever we had an angle that's vertexes on the circle. Because if you look at angle 1 and angle 2, the vertex is going to be right there on that circle. Okay, and so the formula is still the same. The angle is half the measure of the intercepted arc. So it works just the same. So when we look at this example, it just tells us that line M is tangent to the circle. Find the measure of the red arc or angle. So we know that the angle is always equal to half the arc that it intercepts. Okay, and so this is a shorthand of that formula. So in this case, angle 1 is equal to half that arc AB. Okay, so now if I just plug everything in, angle 1, the measure of angle 1 is equal to half of 130. And so half of 130 is going to give me 65 degrees. For the second one, same thing. I'm going to do the angle is half the arc. So when I plug this in, my angle in this case, it doesn't give me a number on, or it gives me the actual number, the actual measure, so I would put in the 125 is equal to half the arc, which in this case, I can't just do 2 letters because this is a major arc. Notice it's really big, and it goes through another point, so I'm going to say it's KJL. Otherwise, if I just say KL, that would be indicating the arc on this side, and I just put in blue. Okay, so when I do this one, half of KJL, to get rid of that 1/2, I'm going to multiply by 2. And so that will cancel that out. Multiply by 2 on this side. And so 125 times 2 is going to give me 250 is equal to the measure of KJL. And this is an arc. So it'll be 250 degrees. In this next concept, we just have intersecting lines, and whenever they intersect along with circles. So as this says, if we have 2 non-parallel lines intersect a circle, then there are 3 places where the lines can intersect. They can intersect on the circle, they can intersect inside the circle, or they can intersect outside the circle. And so this forms different angles. Angles that are inside the circle, they form chords, because those 2 segments going across the circle are what we call chords. Their endpoints end on the circle. Then the measure of each of those angles is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So when we do an example, this will become a little bit more clear. But it's just saying the vertical angle, so I look at just angle 1 here. Okay, the vertical angle across from it, obviously we know they're the same. But to find the measure of it, I have to take 1/2 of the intercepted chords of both angle 1, and its vertical angles intercepted chord on the other side of AB. Then when we have angles that are outside of our circle, we have to actually subtract, so the angle is still half. We have that half all the time, it seems, in a lot of these formulas. The angle is still half, but we have to do the chord on the outside minus the chord on the inside to get the measure. So if you notice, it should always be the biggest. You should never get a negative angle measure on these. It's going to be the biggest angle minus the smaller angle. So if we look at A is going to be, we have a vertical angle, we have angles that are inside, and so our angle inside, so we just think about our inside angle, we said is equal to half both intercepted arcs. Okay, if you go back, we add those 2 arcs together. So when we do this formula, we're going to take half of both arcs, the one that's by the angle we're trying to find, and the one that is intercepted by the vertical. So in this case, I would do, or just to simply write it out, I can write the sum of both intercepted arcs Okay, this is just for you to be able to think about it and how you find these. Okay, so then I can actually use the formula. So the formula is the angle is equal to half, both the sum, okay, but I'm going to fill it out like how they have in this problem, okay, how they put both of them on there. So on this one, my angle I'm trying to find is termed as x. And so the arcs that it intercepts is KL, and the vertical angle that it intercepts is JM. And so if I plug those in, so I'm just going to erase here to put them in the same step, I can just put in their numbers, the 156 plus the 130. Okay, now don't get confused when they start to label, they start to put all the angles on here. So if they had put a measure for ML or they had put a measure for JK, like say they had said this one is 20 degrees. Okay, don't just start plugging in numbers. Make sure it's the one that is the intercepted arc of the angle you're trying to find and the intercepted arc of that angle's vertical angle. So when I do this one, I just need to add those up. So 156 plus 130. And so I'm going to get half of 286 is equal to x. So if I take half of 286, I'm going to get 143. Okay, so this angle measure here is 143. Okay, that means the vertical angle obviously would also be 143. And so technically you could solve this whole circle, or I guess you can solve, you would need at least one of JK, but you could solve for the other two angles, you just can't solve for those other two arcs yet. In B, we have an external point, and so it makes an external angle, an angle that's outside of our circle. And so if we look at our formula again for it, angles outside the circle theorem, we subtract the two intercepted arcs by that angle. Okay, that angle is going to create two arcs that it contains inside of it. So basically the inside part is every part that's inside between the angle lines. Okay, so there you can see two arcs on this one, inside the angle lines, inside the angle lines. Those are what we call the intercepted arcs. And so we're going to subtract. We always do biggest minus smallest. Okay, you cannot get a negative angle. If you get a negative angle, that means that you did the formula incorrectly. You probably switched them. So in this one, right, like I said, we're going to do this difference. We're going to do the subtraction of it. So our angle x, in this case, and we can start off with our angle. Let's just write it out in letters first. So we do have a letter for this one. So angle C would be equal to half the two arcs it intercepts when they are subtracted. Okay, so we always do the biggest angle first. So the angles that are inside, the arcs that are inside our angle. So the big one would be DA. So we would have arc DA minus the smaller arc that's inside of it of DB. So if we fill that out, angle C is our x, what we're trying to solve for. DA is 178 minus DB of 76. And so we get half of 102. And so then half of 102 gives us 51 degrees. Okay. So in this one, angle C up here, or that angle X, is 51. As we look at this next part, it just adds just a little bit more specific. We have a circumscribed angle. A circumscribed angle is still an external angle, but it's when both sides are a tangent. So sometimes, if we go back, we'll be using this middle one. Okay, and I'm just going to kind of erase here. But sometimes we would be using this formula for this kind of problem. When we have that external angle and they're both tangents, we can still use big arc minus the small arc, the intercepted arc. But sometimes they're going to give us a little bit less information. So we're going to need to be able to use this next theorem, which actually uses the central angle that is created. So when we have this circumscribed angle, or this external angle that intercepts the circle with just two tangents, when we are given the central angle like this one does, remember central angles are when an angle that has the vertex in the center of the circle, central, center, okay, try to make that correlation. Then we can use this formula here, okay, where you're going to do 180 minus whatever the measure is of that central angle. So it's a little bit easier setup. So we look at this one, A. This is the same exact kind of problem. So we have this external angle. It is a tangent with both. And so whenever we do it, we're going to use a formula that we just saw, where angle, in this case D, is 180 minus the central angle, which in this case is angle ACB. And so when we plug that in, and we get 180 minus 135. And so when we subtract that, we get 45. And so our angle D, or X in this case, and we could have plugged an X there, is going to be 45. Now B is going to take a few more steps. If you notice here, we have a outside angle, an external angle, okay, that intercepted two tangents. Okay, so that means we can solve for the central angle, but we also have an angle that's on the inside. So let's first focus on what we do know from this problem, okay? I'm not going to really think about X as much at the moment. But this problem, like I said, we can actually solve for the central angle in this case. And so the central angle would be this angle here. It has a vertex of G that's in the center of the circle, and it goes out to the 2 points of tangency. And so from the problem that we just had, or from the theorem that we just had, we do 180 minus the central angle would be equal to the external. And so if I just fill in that formula, like the measure of angle H would equal 180 minus that central angle, which in this case is the measure of EGF. And so if I just plug this in, what I know this one's 30. So I get 180 minus the measure of EGF again. I'm going to go ahead and subtract 180. So 180 minus 180. I get 30 minus 180. And so when you subtract those, it's going to give you negative 150 is equal to negative measure of EGF. And if you would have rather have put a variable in for that earlier, you could have. Right now it's negative, so I would divide by negative 1 to undo that. And so when I do that, I'm going to get that EGF is actually 150 degrees. And so the reason for this, if we focus on that central angle, okay, remember that central angles are equal to the arcs that they intercept. The central angle is equal to that arc. Okay, we don't have to do any special formula for that one. We just do the central angle and the arc. So if I put the 150 out here on the arc, that arc is intercepted also by the X that we need to solve for. Okay, so where X is what we call an inscribed angle. And so if you recall from the last lesson, an inscribed angle is equal to half the arc. And so we just kind of write that inscribed angle is equal to half the intercepted arc. Okay. Inscribed angle is half the intercepted arc. So if I plug that in, my inscribed angle is X, and then it would be half the intercepted arc, which we found to be 150. Okay, so then half of 150 is just going to give us 75. And so X is going to be equal to 75 in this case. Okay, like I said, that one's a multi-step. You just need to be able to identify these inscribed angles and these external angles and central angles, and you have to start combining everything. Okay, now it's going to start to get a little bit more complex. It takes a second, but you just need to, like I said, start identifying what kind of angles they are, and then think about the different formulas we've been going over. And I would also suggest you may want to try to have all these formulas in one place. Whether you just write them all down on the back of a sheet of paper. If you want help, I'm more than happy to help you write them down. But just to have a quick reference.